Today we're going to look at function rules from equations, and specifically we're going to look at this idea that the function given by um, g of u, so specifically we have an input u, is representing the other variable, the output variable within the equation. So you'll see if you look up here, we have an equation here in two variables, okay? We've got the variable u and we've got the variable v, okay? So what you've been used to so far is you've been used to situations where, for example, y equals, I don't know, 3x plus 2, okay? Two variables given here, okay? You have your input x and your output y. When you plot them on a graph, you have your x-axis and you have your y-axis, and this function here would give you a line on that graph. Okay. Similarly, the idea that g of u is your output. So g of u is your output, and your output is represented by a second variable in a two variable equation. So your output g of u is actually the variable v. Okay? So just wrap that around your head for a minute, because what that means is that when you approach this equation here, what you want to do is you want to solve this equation for that variable. So you want to solve this equation for v in order to get g of u, because g of u is equal to v. Okay? So if you get that idea things start to make more sense. So that your input is already given to you. So that's the variable you ignore. And the other variable is the variable you solve for so that you can replace it with g of u. So let's take a look now at this equation. Okay, so we have this equation here, negative 12 u plus 3 equals 8v plus 1. And remember that we're looking to solve for v so that we can actually replace g of u with v. So that actually becomes quite an easy task. So all we have to do here, if we remember our solving equations, is subtract 1 from both sides first of all. That's going to give us negative 12u plus 2 equals 8v. And then we're going to divide by 8 everywhere. Okay, so we can actually even divide this entire thing here by just 1/8 if we so wish, and we're all done. Okay, so what this gives us here is a very simple v equals negative 12u plus 2 all divided by 8. Okay, and you don't need to simplify it any further than that. Khan Academy is perfectly happy with you solving it like that. So let's use these tools right here. We're going to put negative 12u plus 2, and underneath we're going to put our 8, and that is perfectly okay for Khan Academy. Let's take a look at a few more. Again, remember, we're solving for the other variable. Take note, our input variable is u. Therefore, our output variable is v, and we notice that we have it twice in here. So what we're going to be doing is we're going to be getting u to one side and v to the other. So let's take a look. What we're going to do here is I'm going to keep u on this side and get v over onto this side. So what I'm going to do is I'm going to subtract 8v from both sides. And at the same time, I'm going to add 3u to both sides. That is going to bring my u over to the left-hand side and my v to the right-hand side. And I'm going to be perfectly happy with that. So 4u plus 3u is 7u. 8v minus 8v is 0. Negative 3u plus 3u is, so that's cancelled out. That's also cancelled out. And then 2v minus 8v is negative 6v. And then all I need to do now is divide by negative 6 on both sides. And I have v is equal to 7u over negative 6, or negative 7 over 6u. All right, negative 7 over 6u. And that's all I need from here. Okay, so all I'm doing, remember, is solving for the other variable, right? Making sure that all I'm left with is this input variable that that we have right in here, right? Okay, your input variable is given within that function notation, so that's what we're focusing on. Let's take a look at a few more. Okay, simplicity here, right? Notice our input variable is n. Okay, so our output variable is m. We only see it in one place, so this is a really simple one. All we've got to do is subtract 1 from both sides. Okay, and we are done. So this one here is just the same as what we've got above, just with a negative 1 on the other side. Right, all we have to do is subtract 1 from both sides and we're done. Okay, I hope you're starting to get the hang of this. Again, remember, your input variable is a, therefore your output variable is b. You need to solve for b. So with this one here, similar to the second problem we chose, we're going to do both at the same time. What we're going to do is we're going to make sure that our b is on one side and our a is on the other. I'm going to add 3a to both sides here. And I'm going to, because I added 3a here, I'm going to subtract 4b from both sides here. Okay, just making sure you're doing it from the opposite sides, okay? So negative 3a plus 3a cancels out. 4b minus 4b cancels out. And here we have it, 6b minus 4b is 2b. And a plus 3a is 4a. Divide by 2 everywhere. And you have b is equal to 2a. And that's all you've got. Okay, so I think that should be enough to go by. All you need to remember in every situation, remember, is to solve for the other variable. Remember that when you're given this function notation, it gives you the output. So remember that in this case, for example, f of a is b. They're the same thing, right? And all we're doing is solving for b in order to get f of a. The idea that the function is a function operated on the input of a, right? Giving you the output of b. But we don't need to mention b when we're using function notation. So I hope that that clarifies things for you. Give it a try for yourself, and if you've any questions, let me know.